In this video, we want to review transforming functions. Specifically, we're going to look at the quadratic function. So when we think about how can we move a quadratic function, we can move a quadratic function like we can move any type of a function. We can move it up, down, right, left, stretch, shrink or compress, and reflect. So we want to look at all of those different types of transformations and where they would occur in the equation. All right. So if we think about our parent function, here we have f of x equals x squared. That's our parent function because it's our most basic function. All right. So now we want to look at if we wanted to move something up or down, where would that value be? If we wanted to move something right or left, where would that value be? If we wanted to stretch it, shrink it, reflect it, where would that value be? Okay, so I've kind of broken them up into three types of movements that we want to look at. Okay, so we're going to look at a vertical translation. Vertical would be up and down. That's going to be the value being added at the end of our quadratic. Okay, so if that value, if k is greater than 0, so if it's a positive number, all right, so let me add that. If it's positive, we've got a plus k, then we are going to translate the function up, k amount. So if we have a plus 2 out there, we would say it's going to move up 2. All right. Now, if instead we have a minus out there, okay, so we see either a minus, we can think of a subtraction or a negative symbol. We've got that minus k on the outside. Then we're going to think of that being down a k amount. So if I have x squared minus 2, I would say that it's going to move down 2. All right, so if I look down here at our transformations, I see that this plus k is going to be that vertical translation. Plus k going up, minus k going down. All right. Now, if we can move something up and down, we could also move it right and left. So our horizontal translation, we notice that's now inside our function. Okay, it's being inside those parentheses. Okay. Now, one thing to remember with a horizontal translation is it's going to be opposite of what you think. Okay. So what I mean by that is, for example, if I move something to the right 4, I would think, okay, well, I'm adding 4. Well, in the equation, I would see a minus sign. So it's going to be opposite of what you think. What I mean by that is if h is greater than 0, so if I see a positive h, so a plus h there, then I'm actually going to be moving to the left h units. Okay, so if I have x minus 7 squared, then what I'm going to do is I'm going to be moving to the left 7. Okay. If that h value is less than 0, so I've got, you can think of it as seeing a subtraction sign or a negative sign. If I have a minus h, then I'm actually going to be moving to the right h amount. So if I had x minus 2 squared, then I'd actually be moving to the right 2 units. Okay. Now, the next thing that we could do is look down here at our function, as we did last time, and I see this h right here. We can now say, okay, that's going to be our horizontal translation, where I see that I have a plus h is moving left and a minus h is moving right. Okay, so now we've looked at how we can move up, down, right, left The next thing that we could do is we could stretch it, shrink it. So another word for shrink is a compression. I could also reflect. So all three of these things are going to occur in the front of our value being multiplied. So we notice the last two values were being added or subtracted. This is going to be multiplied in front. Okay, so if I think about something stretching is going to be getting bigger. These are all vertical type of stretch, shrink, reflect. Okay, so, and remember, let me add in here that compression is the same as saying shrink. I kind of use those interchangeably there. Okay, so I'm looking at vertical motion. So vertically, one thing I could do is I could take this function and I could flip it from top to bottom. So I could flip it vertically. So what was facing up is now facing down. Or what was facing down is now facing up. So when I look at this, if I am facing up, so let's just look at what a quadratic looks like here. We've got this U going up, or I could reflect that, flip it over. So instead of going up, now we see it would reflect to face down. Okay, sometimes we call this a flip. Okay, we say, okay, yeah, it got flipped over. It's being reflected. That's going to happen when I have a negative in front. So if I have a positive value, okay, then it's going to open up. If I have a negative value, then it's going to open down. So remember, greater than 0 means positive. Then I'm facing up, a regular quadratic. If it's negative, it's going to reflect. It's going to flip over. And I'm going to now open down. Okay. So when I say this, I want to add in here a little bit of vocabulary that we've looked at before. What happens when I have this value at the bottom? Remember, we looked at that before. That bottom value is called a minimum value. Now, if I were to reflect this, I would have a maximum value. Okay, so I'm looking at that vertex. Remember, another way to talk about both of these is to talk about the vertex of the function. And the vertex, we can talk about either a maximum or a minimum. A minimum occurs when I'm opening up. A maximum occurs when I'm opening down. Okay, so that reflection actually does a lot to our graph. So there's lots of vocabulary going along with that reflection. All right, moving on, another thing that could happen when I'm multiplying a value in front of my x squared, this a, is to stretch or compress. Okay, so think about if I were to grab this function by the tip of the graph, the very tip top and the bottom, okay, and I were to pull it vertically, it would stretch, get really, really tall, and I would be stretching that value. That would be if my a is greater than 1, we would see a stretch. Okay, now if I were to instead from the top and the bottom kind of push on it and it gets shorter, it's compressing that down, it's shrinking in value, then I would say it has to be a small value. It's going to be a compression. Okay, again, you could call that a shrink depending on whatever you like to do, however you want to call it. So this value, if I have something being multiplied in front, it's actually doing a lot of different things here. Okay, so let's look at it in our function down below. So we notice that we've got kind of twofold. This a can do two things. One thing it can do is it can stretch it. If a is greater than 1, we're going to stretch. If a is between 0 and 1, it's going to compress. Okay? But then we also have to remember that if a is positive, then it's going to, so I'll write down here positive so we remember what that means. If a is positive, then it's going to open up and it's going to have a minimum value. If a is negative, then it's going to open down and it's going to have a maximum value. Okay? So lots of different things can happen to a function. Up, down, right, left, stretch, shrink, reflect. And it all goes back to the placement of the number in my equation. Okay. Now, one more thing that I want to notice about this equation is we said that it was written in vertex form. Okay, so up here we said in vertex form. Now, if we remember about a vertex, remember a vertex is written, let me write this down, a vertex is written HK. So I can immediately, no math needed, I can immediately find the vertex of my equation by looking at the H and the K. Now I notice that my vertex is H comma K and my equation is negative H comma K because remember it's opposite of what you think for this H. It's opposite. Okay. Now, one more thing that we can get from this is we've talked about that idea of an axis of symmetry, if we remember that. An axis of symmetry is the x value of the vertex. All right, it is the x value of this vertex. So once I found the vertex, then I also have the axis of symmetry. And look, I had to do no work to do that. So I can get the vertex and that axis of symmetry just by looking at my equation. So there's lots of information that we can get just by knowing the placement of the numbers in our equation. So let's look at a couple examples. So let's look at a few examples here. So we want to analyze each of these equations to find every different element that we've talked about here. So first thing that we want to look at is that A. Remember, the A can tell us kind of three main things. It can tell us about a reflection, how we're going to open up versus down. It can tell us about a stretch, a compression, or maybe there's none of that. Okay, so the first thing that we want to do is identify what the A is. So my A here is 2. So let's see how we can answer our questions now. So knowing that the A is 2, it's positive, so there will be no reflection. Since it's positive, it's going to open up. And since that number is greater than 1, it's going to stretch. Okay. Now, one more thing, and I know it's kind of in a weird spot, it's all the way at the end. The other thing that we can do is determine if it's a maximum or a minimum. So again, since A is positive, it's going to be a minimum. Okay. We'll get back to the value here in a little bit. Okay. So let's look at our next value. The next value is going to come from the H. So our H value here, remember, it's opposite of what we think. So our H we're going to use here is a -1, opposite of what you think. So because it's a plus in the equation, I'm going to be moving to the left 1. Okay. I can also start my vertex with my -1, remember it's opposite of the equation. I have to come back for the K part. And I can get the axis of symmetry to be x equals -1. All right, so the last value that we want to look at is that K value. So our K, it's exactly what we see in the equation, so it's -5. So that k value, that negative 5, means that we're going to move down 5, okay? Which means our vertex is going to have a negative 5 with it. And that is actually going to be the value of the max or the min. So we can say that we're going to have a value of negative 5. So we find if it's a max or a min by looking at our A value. Then we find the value by looking at the K value. Okay, so we're going to do it all over again a couple times just to make sure that we really are understanding. So first thing I'm going to look for is the A. My A here is a negative, and if there's no number, we're going to use a 1. So a negative 1, let's see what that does. It's going to actually make us reflect. Now that we reflect, we're going to open down. Okay, my negative 1 is not a stretch or a compression because it's really just the 1. The negative meant that it was reflection. The 1, okay, it's two separate things, means that I have neither here. Okay. Now, because it is negative, that's going to make us have a maximum for the function. Okay, so now that we're done with our A, let's go over to our H. H is a negative 3, so I'm going to change that because a negative is really going to move to the right 3. And that means that our vertex is going to be a positive 3 for the first value. Our axis of symmetry is going to be x equals 3. Okay. Moving along to our K. Our K value is a 1 here, which means that it's positive, so it's going to be moving up 1. That's the value of our vertex, the Y value, and that's going to be the value of my maximum. Okay, starting over, here we go. Hopefully by the end we kind of get into the groove of what's going on. We're going to look for our A. Our A is 1/2. It is positive, so there is no reflection. Since there's no reflection, it is going to open up. It is a number that is between 0 and 1, so it is going to be a compression. Okay. Since it is positive, it is going to be a minimum for the function. Let's look at our H. Our H here, we're going to change that positive 4 to a negative 4 because we're going to be going left 4, which means I'm going to have an H of negative 4 for my vertex. And my axis of symmetry is going to be x equals negative 4. Our K, we're missing a K. That's going to be a 0. So we do not move up or down. So I'm just going to put none. That means we'll have 0 as our K. So the vertex will have a value of 0 and the minimum will have a value of 0. Okay, looking at our next one. We're looking for our A. Our A is a negative 1. That means since it is negative, we are going to, yes, reflect, which means that now we're going to open down. Again, because it's just a 1, we will have neither a stretch or a compression. Okay. But because it is a negative 1, that means we will now have a maximum value. Okay. Let's look at the H. Oh, there's no parentheses. There is nothing inside the function, so our H is going to be 0. So we do not have any right or left motion, none. Which means that we have 0 for our H value. So x will equal 0 for the axis of symmetry, and the x value of the vertex is going to be 0. Okay, let's look at our K. Our K is negative 6. Okay, Remember, do not get confused. That -6 is the K, not the H. To have an H, I need parentheses, okay? So that -6 is actually our K. Since it's negative, that means we're going to be going down 6, which means we'll have a -6 for the K of our vertex, or the Y value, right? Which means we'll have a -6 for the maximum value. All right, last one. Hopefully by now you've probably already passed me up and you're already going along here. We've got an A to be -3. It is negative, so that means yes, it is going to reflect, which means it's going to be opening down. There's a 3, so I actually will also have a stretch. Okay, now this is where some people might get confused because you're like, wait, -3 is not greater than 1. No, no, no. Remember, the negative is for the reflect, and just the 3 is for the stretch. Okay, so the negative goes for the reflection and the 3. It's like they're doing two different things. Okay, now because it is negative though, I'm going to have a maximum. Right? So that one had a little trick to it there. Let's look at our H. I see a -2, which means I'm going to make that a +2. I'm going to now be going to the right 2, which means I'm going to have a +2 for my H value. And my axis of symmetry is going to be at that +2. My K value here is at 4, which means I'm +4, so I'm going to be going up 4. My K value for my vertex is going to be a +4, and my maximum value will be a +4. So hopefully now we can look at any equation and be able to analyze knowing and locating the A, the H, and the K. So we can describe, does it reflect? Does it open up? Does it open down? Does it stretch, compress? Does it have a maximum or minimum? We can look, does it go right or left? Does it go up or down? Find the vertex, locate the axis of symmetry, and decide what the max or minimum value is just by looking at my equation.